Okay, so good day, grade 8 max size students. So for our third lesson, we have here our third module for the fourth quarter. Okay, so we have here chords and tangents to a circle. So you've already been introduced to the concept of a chord. Okay, so a chord is a line segment that is found on a circle. And a tangent is a line on a circle that intersects the circumference at only one point. Okay, so you can see here on our illustrations that we have a lot of tangent lines and a lot of chords. Okay, so for this one, okay, so let's say for example, we have here this line. Okay, so this line, okay, let's say for example, BK. Okay, so BK is tangent to circle R and circle P. So those are tangent points. And we also have, let's say for example, this letter here. Let's say this is letter Z. Okay, let's say it's letter Z. So ZD here is a chord. Okay, and also in a lot of geometric constructions we use the chords and tangents. Okay, so just for example, these are the tomes or the pedestals where Newton and Leibniz wrote their books about calculus. Okay, so there you go. So we have those pedestals for those books for Newton and Leibniz. Okay, so we're going to try to discuss not the book, okay, not the book by Newton and Leibniz, okay, so Principia Mathematica, but what we're going to discuss is the properties of chords and tangents and how they relate on a circle. So before we do that, okay, so let's just try to unlock some vocabulary, mathematical vocabulary. So we have here on the image, the first image here, we have your concentric circles. Concentric circles are circles who are not tangent to each other. So they do not intersect each other, and they only have one center point, which is point O. Okay, so these three circles here, circle 1, circle 2, and circle 3, they all have one center point, which is point O. But for this one, for this circle, eccentric circles, so eccentric circles have different center points. Okay, so for the first circle here, the blue circle, the center is point O. For the second circle, the center could be here. And for the third circle, the center could be here. Okay, so there you go. Those are our two types of sets of circles. Two types of sets of circles. So we have the concentric circles. They have a center point, a common center point, the circles there. And then the eccentric circles. So these are circles with different center points. Okay, so after unlocking some vocabulary, let's go to the proofs, okay, or theorems regarding tangent and chords, okay, and chord angles. Okay, so we have the tangent chord angle theorem. This states that the measure of an angle formed by a tangent and a chord is half the measure of its intercepted arc. So we have here circle T, okay, and we have here a tangent line, okay, G. Okay, let's say that the line is G. So therefore, okay, the angle here, angle G, the measurement of angle G is going to be equal to 1/2 of the measurement of its intercepted arc, which is LG for this one. Okay, and for this one, okay, for this circle right here, we can do it the other way around. Okay, so this one. Okay, so if this goes from this one, this also goes from this one. If you want to get the measurement of this arc, then you just need to find the measurement of this angle. Angle DG, okay, let's say this is O. Okay, so there you go. So DGO. So there you go. But to get the measurement of angle G for this one, okay, so since this is A, okay, so the measurement of angle G or DGO, okay, so angle G is equal to 1/2 of DAG. Okay, so this is DAG, this arc right here, the major arc. Okay, so those are our tangent. Those are our two types of circles for the tangent chord angle theorem. And let's try to solve some problems involving these two types of circles. Okay, so for the first one, Isa is building a new sprinkling system for her ICT project. Using automated systems design systems, she is able to map the trajectory of water releases from a given water nose. So given that point Y is a sprinkler with a trajectory tangent to circle T, at the point of tangent CI, find the measurement of angle HUI, okay, so this angle, and also the measurement of angle UIY. Okay, so first let's try to find the measurement of angle UIY. Okay, so we have here the measurement of angle H is equal to 35 degrees. So using the theorems that we had a while ago, okay, the chord tangent theorem, so therefore we can say that since the measurement of angle H is equal to 35, therefore 35, okay, so the measurement of angle H, okay, the measurement of angle H is going to be equal to 1/2 of the measurement of this arc right here, okay, of arc IU. Okay, so the measurement of arc IU. Okay, so we need to find the measurement of arc IU. So to do that, we just write here 35 is equal to 1/2 the measurement of arc IU, then multiply to 2, therefore the measurement of arc IU is equal to 70. Okay, so we just found the measurement of arc IU, but we still haven't found the measurement of this angle right here. So how do we get the measurement of that angle? Okay, next we can also say by finding the angle here, the measure of angle UIY. Okay, so the measure of angle UIY is going to be equal to 1/2 of the measurement of this arc right here, the measure of arc IU. Okay, so they're also going to be equal to each other. Okay, because of the, okay, let's go back to that theorem. Okay, to the tangent chord theorem, the measure of an angle formed by a tangent and a chord is half the measure of its intercepted arc. So this is a tangent and this is a chord, so this angle right here must be 1/2, okay, of its intercepted arc, which is IU. So this is going to give us measure of angle UIY is going to be equal to the measure of angle H. Okay, so the measure of angle H, so therefore the measurement of angle UIY is going to be equal to 35 degrees, because 1/2 the measurement of IU, okay, so this arc we have already solved, that is equal to 35, and we've measured IU, so that's 70 divided by 2, so that's going to give us 35. So how about the measure of angle of angle HUI? So what's the measurement of this angle right here? So we can look at the intercepted arc. The intercepted arc is going to be HI. So we need to find the value of HI. So how are we going to find the value of HI? So we're given here HU. We can see that HU is a semicircle because its diameter, because it has a line that passes through the diameter, and we know that the diameter forms a 180 degree angle. So therefore this is going to be equal to 360 minus, okay, the measure of arc HU plus the measure of arc IU. Now we know that the measurement of arc HU, okay, 360 minus the measure of arc HU is equal to 180 degrees, since again this is a semicircle, and the measure of arc IU is equal to 70 degrees. We can now solve for the value of arc HI. So this will give us 360 minus 250, and 360 minus 250 is equal to 110 degrees. So this is the measurement of arc HI, 110 degrees. And again, using the theorem, since this is an arc and we're just looking for the angle right here, the measurement of angle HUI is going to be equal to 1/2 of the measurement of arc HI. And we know that the measurement of arc HI is 1/2 times 110. Therefore, the measurement of angle HUI is equal to 55 degrees. There you go. So we have our answer right here. the measurement of angle UIY is 35 degrees. The measurement of angle HUI is 55 degrees. Okay, so let's go to our next problem. So we have here Rolando is building a space shuttle in ISS Haribon, the International Space Station of the Philippines, in 40 years from now. So asteroid and other miniature celestial bodies, one of which intersects and collides with ISS Haribon at point W, is seen on the image on the right. So to prevent another collision course from happening, Rolando must discover the measurement of angle T and the measurement of arc BW, and also the measurement of angle Y here. Okay, so how do we solve for that? So using our knowledge about the chord tangent angle theorem, or the tangent chord angle theorem, and also about inscribed angles and intercepted arcs, we can solve for the value of angle T, BW, and angle Y. Okay, so first let's try to solve for angle T. This is the easiest part. So we can see that T and 120 degrees are linear pairs. Okay, so therefore to get the measurement of T, we just simply have to minus 180 and 120 degrees. So since they form a linear pair, so this will give us that T is equal to 60 degrees. Okay, T degrees is equal to 60 degrees. To find the measurement of Y. Okay, so how do we find the measurement of Y? So we can again recall the tangent chord angle theorem. Okay, so it says that the measurement, okay, of a given angle, let's say it's W here, is equal to 1/2, okay, 1/2 of the measurement of our arc. So for our arc, it's simply Y, okay, because there's no point that's been labeled here. So we have here the measurement of arc Y. So this will give us the measurement of angle W is 120 degrees is equal to 1/2 the measurement of arc Y. So therefore, okay, multiply this both by 2. Okay, so therefore the measurement of arc Y is equal to 240 degrees. Okay, so there you go. The measurement of arc Y is equal to 240 degrees. Okay, so we have the value of T and we have the value of Y. We can now solve for BW. So what is the measurement of arc BW? Okay, so it's going to be simply equal to 360 minus the measurement of arc Y. And we know that the measurement of arc Y is equal to 240 degrees. So this will give us 120 degrees. The measurement of arc BW is equal to 120 degrees. And that's the first part of our chords and tangents, circles, theorems for this lesson.